Group. A very good morning to you all. Now, today I am going to start with the last topic, invertible functions. Now, in this invertible functions, I will first explain you what are invertible functions. Let f from a to b be the function. Then, if f is 1 1 and onto, then it is invertible. I mean to say, if f is 1 1 and onto, then you have the function g from b to a. So g is inverse of f. So again I am repeating, let f from a to b be the function. Then if f is 1 1 and onto, it's invertible. That is, you have the function g from b to a, and g is inverse of f. So for proving that function is invertible, you have to first prove that f is 1 1 and onto, and then you can write inverse directly. Else you have, for the function f from a to b, the function g from b to a is inverse of f from a to b if FOG of y is y for all y belongs to b, and GOF of x is x for all x is in a. Again I am repeating, the function g from b to a is inverse of f if FOG of y is y and GOF of x is x. So for invertible function, either you use this definition or this definition. So I will give you numerous examples to let you know which definition you can use. Now, you'll write define f from R to R as fx equals to 4x plus 3. Show that f is invertible and find f inverse. Show that f is invertible and find f inverse. Now solution. You will first show that f is 1 1. F is 1 1. Now for showing f is 1 1, you will write let x1 and x2 is in R domain. So you have f of x1 equals to f of x2. This means 4x1 plus 3 equals to 4x2 plus 3. Well, this will give me 4x1 equals to 4x2. This gives x1 equals to x2. So f is 1 1. Now for onto you have for let 4x plus 3 equals to y. So x is y minus 3 by 4. Now as y belongs to R, that is codomain, so y minus 3 by 4 also belongs to R. So x belongs to R, that is domain. So f of y minus 3 by 4, this is 4 times y minus 3 by 4 plus 3, that is y, but this is x. So for every y belongs to y, there is x belongs to x, is that fx equals to y. So f is on 2. Now since f is 1 1 and on 2, it's invertible. Now after showing that 1 1 and on 2, you can write the inverse directly. What is inverse? X is y minus 3 by 4. So you can write f inverse y directly as y minus 3 by 4. So that is the inverse of the function f. See, this is the one method. Now the another method, I will use the method of composite functions, and I will show you how to get the inverse of that function. Now you have f from R to R defined by fx equals to 4x plus 3. You will write, let 4x plus 3 equals to y. So x is y minus 3 by 4. Now you suppose this as gy equals to y minus 3 by 4. So you have f of g of y. This is f of g of y. This is f of y minus 3 by 4. That will be 4 times y minus 3 by 4 plus 3, that is y, for all y belongs to R. That is codomain. Now, in the same way, GOF of x is g of fx. This is g of 4x plus 3. Well, this is 4x plus 3 minus 3 by 4. This is x for all x's in R. So, here you can write as FOG of y is y and GOF of x is x for all x's in R. For y in R, f codes domain, f is invertible. And you have directly f inverse x or f inverse y is y minus 3 by 4. So either you use the method of 1 1 and onto-ness, either you use the method of this. I will take up another question to show you both of the methods. At last you have to decide which method is easier. Now, I define two functions f from 1, 2, 3, 4 to 10 as f equals to 110, 210, 310, 410. Find whether f is invertible or not. So you will write f is not 1 1. See, once if we have seen that it's not 1 1, it's not invertible. As let 1 2 belongs to 1 2 3 4. So you have f of 1 is equals to f of 2. This means f of 1 equals to f of 2. Now what is f of 1? It's 10. What is f of 2? It's 10. Now f of 1 equals to f of 2 equals to 10 means 1 is equals to 2. This is not possible. You can see in that way also. 1 is not equals to 2, but f of 1 is equals to 10, f of 2 is equals to 10. So you have f of 1 equals to f of 2. So I have shown both ways. So f is not 1 1 Hence, f is not invertible. So like this, if the function is invertible, I will now tell you how to find f inverse. Now, suppose f from 1 to 3 to 1 to 3 be defined as f equals to 1 to 2 3 3 1. Show that f is invertible and find f inverse. Now f is 1 1 as 1 is not equals to 2 implies f of 1 is not equals to f of 2. You can see f of 1 is 2, f of 2 is 3. 2 is not equals to 3 implies f of 2 is not equals to f of 3. 1 is not equals to 3 implies f of 1 is not equals to f of 3. So f is 1 1. Now f is onto. F is onto as for every element in 1 2 3 that is codomain. There is pre-image of every element. As you can see, pre-image of 3 is 2, pre-image of 1 is 3, pre-image of 2 is 1. So f is onto. So f is invertible. Now, since f is invertible, it inverse of this is reverse of this. F inverse is 2 1, 3 2, and 1 3. See, it's the reverse of the ordered pairs. If you find FO F inverse, you will get at last as FO F inverse of x is x for all x in 1 2 3. And same, F inverse OF of x is x for all x's in 1 2 3. This I can give you as exercise. You can attempt that way. Now, the last question. After this, I will give you many assignments, and after this one concept I will tell you, and then we can complete this topic. The last question from the NCERT only I am taking. Consider f from r plus 2 minus 5 to infinity as fx equals to 9x square plus 6x minus 5. Show that f is invertible and find f inverse. Now, I will show you both the methods, method of composite functions and method of 1 1 and onto also. Now, solution. Now, you will write f is 1 1. Now, let x1 and x2 belongs to r plus. See, r plus is all non-negative reals, whereas r plus this is all reals excluding 0. So there's difference in r plus and r plus. So you have f of x1 is equals to f of x2. This will give me 9x1 square plus 6x1 minus 5 equals to 9x2 square plus 6x2 minus 5. Now you cancel minus 5 and minus 5. You have 9x1 square plus 6x1 equals to 9x2 square plus 6x2. Well, this will give me 9x1 square minus 9x2 square is minus 6 times x1 minus x2. Now this will give me x1 minus x2 is 9x1 plus 9x2 plus 6 equals to 0. Now as x1 and x2 belongs to R plus 9x1 plus 9x2 plus 6 is greater than 0. So since this is greater than 0, you have x1 minus x2 equals to 0. So you have x1 equals to x2. So f is 1, 1. Hope it's clear. It's a good question. You have to do a lot of calculations, but it's okay. Now, for showing that f is onto, you will write let 9x square plus 6x minus 5 is equals to y. So you have 9x square plus 6x minus 5 minus y equals to 0. So x equals to minus 6 plus minus 36 minus 4 into 9 into minus 5 minus y upon 18. So that will be minus 6 plus minus this is this will be 36 plus 180 plus this is 36y by 18. So this is minus 6 plus minus root of 216 plus 36y upon 18. Now take 6 common, you have minus 1 plus minus, this is y plus 6 by 3 after cancelling 6 from both the sides. Now as x belongs to R plus, so x is equals to root of y plus 6 minus 1 by 3. Now since x came in the y form, so that is gy. So you have x is this and f of x is equals to f of root of y plus 6 minus 1 by 3. This is 9 of root of y plus 6 minus 1 by 3 whole square plus 6 into root of y plus 6 minus 1 by 3 minus 5 will come. Now solve this, you will get this as y. So f is onto and its inverse is, so its inverse is f inverse y is equals to root of y plus 6 minus 1 by 3. So by the method of 1, 1 and 2 we got this. Now if we want to apply for the method of composite functions, you have fx is equals to 9x square plus 6x minus 5. G of y is root of y plus 6 minus 1 by 3. So what you have to do, you have to write f of g of y is f of g of y. This is f of root of y plus 6 minus 1 by 3. You just put in the expression of f root of y plus 6 minus 1 by 3 whole square, 9 outside, plus 6 of root of y plus 6 minus 1 by 3 minus 5. Show that this is y for all y belongs to minus 5 to infinity. So that is for the composite function. And similarly you have show that g of f of x, this is g of f of x, this is g of 9x square plus 6x minus 5. This you substitute here. In the root you have 9x square plus 6x minus 5 plus 6 minus 1 by 3. This is x for all x is in R plus. So you have g of y is root of y plus 6 minus 1 by 3. Now one more thing I want to tell you, that for ontoness, for y belongs to that your as x belongs to R plus, y belongs to minus 5 to infinity. Now to just show that y belongs to from minus 5 to infinity, you have y belongs to minus 5 to infinity. Now you have to show that how y belongs to minus 5 to infinity. Now class, how to prove that y belongs to minus 5 to infinity? See, y belongs to minus 5 to infinity, then only x belongs to r plus. Now in this method, if it is required, you have to prove this. Okay. Yes. As this minus 1 plus minus root of y minus 6 is 0 only when y plus 6 is greater than or equals to what? Greater than or equals to 1. So that this becomes, x becomes in r plus. Now this is greater than means y is greater than or equals to minus 5. So y belongs to minus 5 to infinity. So actually this also you have to add this to get this onto. Now class, last, I told you that f from minus pi by 2 to pi by 2 to minus 1 to 1 as fx equals to sin x is 1 1 and on 2. So it's invertible. So the function g is defined as g is from minus 1 to 1 to minus pi by 2 to pi by 2 as g of x equals to sine inverse x, as g of x is sine inverse x. So that is again the invertible function. This is the domain, this is the range. So this is domain of sine inverse x, this is range. Likewise in inverse trigonometry, we have this as domain, this as range, which you have to remember. Class, I stop the class here. Hope you have got everything. After this, I will give you the assignments and the questions which you have to avoid in relations functions. Thank you very much.